So basically, I'm going to talk about this my experience with enabling Eclipse OpenJ9 runtime as a Java runtime for Apache OpenWhisk. So Apache OpenWhisk is a serverless platform. Basically, it is equivalent to AWS Lambda, or Oracle has open sourced a new project which is FN. It's equivalent to that project, and there are so many serverless frameworks are available in the market. So Apache OpenWhisk is the leading one. So Apache OpenWhisk supports different programming languages like Node.js, and Java is one of the supported programming language. So the developers can write their business logic in terms of functions, and they can deploy it onto that framework. Then they don't need to worry about on what platform or what runtime it's running on. So it's everything is taken care by the framework itself. So basically, it's a developer's point of view. It is like writing a business logic and deploying it onto that platform. Then they don't need to worry about the other stuffs like allocation of VM, allocation of the required memory, and workload varies based on the workload. What is the scaling policy? Everything is taken care by the runtime. So Java is one, since Java is one of the supported language runtime. It's very important for the for that runtime to take care of these kind of workload, right? So basically, we have done some experiment with Java runtime. So initially, Apache OpenWhisk, when it was open sourced, Oracle JDK was the default runtime for Java actions. And it doesn't have any optimizations with respect to the need of the Apache OpenWhisk. So so basically, I'll start with what is that need of Apache OpenWhisk. Basically, it looks for a faster startup and faster execution. Basically, the customers deploy the code and expect that a function should be completed in a faster enough that they can shift from one function to another function, and there can be a series of function can make up the complete business logic. So every time a new function is invoked at runtime, the framework brings up a new container, and container is like whenever a new function starts up, the container will be spawned, and on top of that container, the code will be deployed, and the execution starts from there. The business logic of the execution starts from there. So basically, they look for they basically the framework looks for trying to accommodate more containers in a given restricted or environment. Like given a VM, I want to accommodate a number of containers, running containers at the same time, so that I can maximize that utilization of that particular resource. So that kind of expectations from the framework. Yeah. So we have done some studies using the existing the default runtime and the Eclipse OpenJ9. So basically, it's a simple action. So action is nothing but a code which is expected to run it on the framework. So I picked up on code which is a simple QR generator. So basically, given a string, it will convert convert into a QR code, and that will be that can be used for a QR code kind of thing. So basically, so I deployed that code onto that framework, and trying to understand what is the startup time with respect to hotspot and the Eclipse OpenJ9. So for example, if you look at this the startup time of hotspot without any parameters, the default, the vanilla hotspot runtime. So the startup time somewhere sits here. And with OpenJ9, we saw that it's more time. But when we apply the pre-built cache of um, uh, uh, pre-built cache for the OpenWhisk action, then the startup time comes close to that hotspot runtime. So, but at the same time, if you look at the memory usage of that particular action, so it basically varies. The difference is huge. Basically, if you look at the difference, hotspot uses a larger, very huge memory, and compared to OpenJ9, in the sense it uses 1/3 of the hotspot. It could be like what we have found is it's hotspot is very aggressive in expanding the heap, and that's the reason we see that hotspot has expanded the heap as large and enough that it can execute faster. But at the same time, if you look at OpenJ9, it's able to meet the same execution time. At the same time, it's able to use a lesser memory. That was the observation. These observations has made and convinced that now Eclipse OpenJ9 as the default runtime for Java actions on Apache OpenWhisk. So this is what where we started and where we ended. In the sense, Oracle hotspot based Java runtime for Eclipse, Apache OpenWhisk, and from there we moved on to adopt OpenJDK based OpenJ9 runtime for Java actions. That's where we ended. It has been contributed and it has been accepted. It has been merged. So that was the thing. So if you have any questions, I can address that. Yeah.
Thanks so much, Param. It's really interesting to see OpenJ9 getting adopted. Was it primarily the footprint that led to the interest from the OpenWhisk community?
Yeah, footprint and even the shared class cache capability also interested them to basically with shared class cache. They see that hotspot able to meet the hotspot startup time and the footprint. Yeah, so both. They did not do any. So basically, Apache OpenWhisk team doesn't have any runtime experience as such. So they have not done any study with respect to doing some kind of experiment with tuning the runtime options like that. So when we applied all this shared class cache and the observation with respect to memory usage, which basically interested them towards Eclipse OpenJ9. Yeah,
that's great news.
Hi, Param. That's a really great result. Have you spent any more time looking at tuning the shared class cache result? Like, I'm just curious how big a shared class cache you're using, if you know it's full, that sort of thing.
Yeah. So basically, I started with the default cache. I have not done any more study with tuning further down, like reducing the shared class cache size or anything like that. So basically, as a starting point, I started with the default size, and what I've done is I've pre-built it for the Java whatever the SDK class is required for bring up the Java runtime. Plus, there is a HTTP server is required for the runtime the Java actions to run on. So basically, whenever we invoke an action, it's nothing but bringing up the container, bringing up the Java runtime, bringing up the HTTP server. Then only it starts the actual action code deployment and then executes. So basically, they have the two different stages. One is the initialization stage and the execution stage. The customers, the basically end users, developers are charged for the execution stage, not for the initialization stage. So basically, they are very much concentrating on the initialization time so that they can reduce further and give the more benefit to the developers. So basically, that's the reason they are more towards startup time and the performance and accommodating more containers. So if you look at for your question, I have not gone to the next step of looking at other tuning with respect to shared class cache. I just started with the default cache and just dumped only the classes which are required for the runtime startup, the basically Java runtime startup plus HTTP server startup.
Okay, cool. I'd be interested to see if the performance results improved or not with using something like Dash Xtune virtualized, which might more aggressively put AOT code into that shared class cache, which might help even further with the initialization time. Perhaps, I don't know. Anyway, very interesting results. Thanks for telling us about them.